Here is where I will explain several interesting things that we run into with absolute values. First of all, let's repeat the thing that we already saw. If I have x to the 20 and I try to take the fourth root, then it's going to, well, let me go ahead and break it out so you can see it. X to the 20, and we try to take the fourth root. If I try to do this, what ends up happening is I end up with x to the fifth. And as you'll recall from the last video, if I have an even power and an odd result, then I'm going to need absolute values. So I just go ahead and I put them in there. Okay, so that's the same thing from that's this basic rule. Let's take a look at some different things, exceptions, I guess we'll call it. So the other thing is, what about this y to the eighth? If I have y to the eighth and I try to take the fourth root of that, what I end up with is y squared. Now what you'll notice here is I start with an even power and I end up with an even result, and so there's no reason for absolute values. Okay, so that still follows this rule perfectly. But here's where a little weirdness happens. See, oh, actually no, this isn't so weird. So I start out here with an odd power. So since I start out with, yes, this is a little weird. I start out with an odd power, but I'm still going to have absolute values in the end. So this is a little strange. Check this out. I'm going to go z to the 37th power. Oh, I'm going to rewrite it as z to the 36 times z. Okay, z to the 37 is z to the 36 times z. So I'm going to go ahead and write that out as a fourth root. Now, when I have this z to the 36, this is the same as z to the 36 fourth root times fourth root of z. Now this guy cannot be simplified, this fourth root of z, so I just leave it. But this can be simplified. And what you'll notice is, again, that we start off with an even power. So we have to be a little bit paranoid about what's going to happen next. This will turn out to be z to the ninth, which again, you'll notice is now an odd result, odd powered result, and so therefore, boom, we put in the absolute value. So if I wanted to simplify this correctly, I would have to write my answer in the end as x to the fifth with absolute values times y squared with no absolute values times z to the ninth with absolute values. And of course, don't forget about this guy over here. We still have the fourth root of z, which just cannot be simplified. And so this would be our final answer. All right. So again, kind of a weird case where we start out with an odd power, but we still end up with absolute values because we break that odd power up into z to the even power times another z over here. All right, just wanted to give you a heads up that you might see something like that. Again, this is awfully difficult for a tiny little result. There's way more important stuff that you should be able to do. Like, I'd really love it if you could learn how to take the fourth root of x to the 20 and get x to the fifth. That's important. Y to the eighth, take the fourth root, get y to the second. Really important stuff. This other stuff with the absolute values, it's a nice to know.